going to use those compound angle identities that I wrote on the blackboard. So the first one, number 3, you have sine x plus 45 degrees. Okay? Now, I want you to be aware that when you write metric, the information sheet, in terms of the angles, it doesn't use x or y. It uses alpha and beta. That's why I wrote my angles there in terms of alpha and beta. Okay? So what you do, I'm sure you can see that we have got sine here, right? And there is an addition of 2 angles, which means we are using number what? 3. Number 3. Okay? What that means is your x here is like your alpha there. And your beta there is like the 45 degrees. Okay? Please take note, we are just expanding and we are also simplifying if it's possible. So last year in grade 10 you did special angles. You should know that 45 degrees is a special angle and it's equal to 1 over square root of 2. It's not, okay, generally you don't write it as root 2 over 2. Okay? So if I do the expansion, okay, obviously I'll start with sine alpha, which is x. Okay, then remember the alpha is like x, right? So sine x times cos 45 degrees, because beta is like 45 degrees, right? Then I'll put my plus here, then I'm going to repeat again. I'm sure you can see that I've got cos now, cos alpha, so it now becomes cos x. Okay, I started with sine x, I can't have sine x again then. It has to be the opposite, so it will be cos x times sine 45 degrees. Okay, I'm using number 3, right? Then the question here says simplify if it's possible. Now, this expansion can be simplified because we know what sine 45 is, what cos 45 is, right? So I can simplify and write this sine x times 1 over square root of 2 plus cos x times 1 over square root of 2. Okay? Which I can rewrite by factoring out 1 over root 2 is 1 over root 2 times sine x plus cos x. Okay, so that's the expansion in simplified form. All right? Are you following that? Any question? Right. Is there anybody who's got a question? Please, if you did the homework, just mark your work. All right? If you didn't factorize here, like for example, let's say you have the 1 over root 2 in front of the sine x and the 1 over root 2 in front of the cos x, it's correct, but you can move on to the next step where you do the factorization. Right? Sorry? Yes, but you must look for special angles. Whenever you have, yes, whenever you have got an expansion in their special angles, then you need to simplify. Remember your special angles: 30 degrees, 45, 60 degrees, 90 degrees. Okay, you have got 180, 270, and 360. Those are special angles. All right. Then number 4. So number 4, you have cos 30 degrees minus 5x. Cos 30 degrees minus 5x. Right? We are expanding and we also have to simplify. Can you pay attention? Pay attention. Right? Now, which compound angle identity can we use here? The first one, that's the mother. Okay? We have to use the first one because of the minus between the angles. Okay? Because of this minus between the angles, we use the what? The first one. So our alpha always, I'm going to encourage you to have a second color that you can use. So this 30 degrees is like alpha, the 5x is like what? Beta. Okay? Then we expand, so that will be cos 30 degrees. Okay, this is a minus obviously, so that will be times cos 5x. Okay, I'm sure you can see that beta is equivalent to 5x. Since there is a minus here, we put a plus like that. So that becomes plus sine 30 degrees times sine 5x. Right? Now we know that 30 degrees is a special angle. Right? Therefore, cos 30 is the same as square root of 3 over 2 times cos x, cos 5x, right? Plus sine 30 is the same as a half times sine 5x. Okay, then you are done. So again, if you did the homework, just mark your way. Okay, if you made a mistake somewhere, then you can do the corrections quickly. Right? I'm using this form. Right? Huh? All right. Let's move on. Right? For B, which questions did I give? B4, B4, and then B7. Okay. Now here we are now doing the reverse now. The question says, write the following as a single trigonometric ratio. So we are now moving from the right hand side of these four identities towards the left hand side. Okay? Remember, the right hand side is a combination of two trigonometric ratios, sine and cos. But the left hand side will only have cos only or sine only. Okay? So we need to simplify this until we get one trigonometric ratio. So number 4, we have sine 43 degrees times cos 33 degrees minus cos 43 degrees, right, times sine 33 degrees. Right? Now, among those four identities, which one do you think is the appropriate one?
The last one.
Huh?
The last one.
It will be the last one because there is a minus here and there is a product of sine and cos. Okay? So we use the what? The last one. Right? But I would suggest here that you also identify your alpha and your beta. So the 43 degrees is going to be alpha because it is the largest of the two angles. Okay? The 43 degrees is going to be alpha because it is the largest of the two angles. And cos 30 and the 33 degrees is going to be beta. So this is alpha, that's what? Beta. Since there is a minus here, okay, when we do the expansion, it will be equal to sine 43 degrees minus 33 degrees. Because alpha is equal to 43 degrees and beta is equal to 33 degrees. Yes. Yes, always. That comes from the proof. Okay, remember, for the proof we said alpha minus beta. Yes. You don't start from the second term, you identify your alpha first from the first term. Okay? You identify your alpha first from the first term. Alpha and beta, you identify them from the first term. Right? So this will be equal to sine 10 degrees. Right? And then you are done. Now, if you are clever, you can check with your calculator. you can put this in your calculator, right? And get an answer as a decimal. And then put sine 10 degrees and also get the answer as a decimal. The answers must be equivalent. Okay? So if you put this whole expression in your calculator, you must get the same answer as putting sine 10 degrees in the calculator. Some questions may also require you to apply your knowledge of core ratios. Okay? Some questions require knowledge of core ratios. So at this stage, all your knowledge of trigonometry from grade 10 and especially grade 11 is required. Okay? Any question? All right, don't have a question, then let's move on to number 7. So number 7 is sine x minus 20 degrees times cos 20. Okay, then there is a plus and then we have got sine 20. Okay, so here we also need to simplify until we get one trigonometric ratio. So first thing, identify your alpha and your beta. So in this case, let's consider that x minus 20 degrees as our alpha. Okay, and then the 20 degrees as beta. Right? If we do that, it means we are going to use which one of the 4 identities there? Number what? Number 3. Okay? We have used number 3. So this will be equal to sine x minus 20 degrees plus 20 degrees. And the answer that you will get will be sine x. Because minus 20 degrees plus 20 degrees gives you a 0. Alright? Are you following that? Yeah. Don't be tempted here to expand this sine x minus 20 degrees. If you do that, you'll be complicating the question. Okay? You create some terms that are not easy to simplify. Alright? Any question? Right, then for C, which question did I give? Huh? C3 and C6. C3 and C6. Right? So, right. If I didn't do a question under any exercise here, then you must do it as part of your practice. All right. So this will be sine beta plus 60 degrees minus cos beta minus 30 degrees. Okay, the question says simplify the following. Now here, we are not told much. The question just says simplify. So my suggestion, in order to do this question here, you expand this expression for sine, also expand that expression for cosine. Okay? That's the only way, using the appropriate identities among those 4. I'm sure you can see that here there is a plus here, so we use number 3 here. Then there's a minus there, so we use number 1. So let me do the expansion. It's going to be a long expansion. So this will be sine beta times cos 60 degrees, right? Plus sine 60 degrees times cos beta. Please be aware that I generally, in my case, I prefer to start with sign for the identities for sign there. I prefer to start with sign here and there. But because of multiplication, you can put cos beta first, then sine 60 degrees. It's the same thing. Okay, but in my case, over the years, I prefer to start with sine. Okay, then from here, we have got this minus, so it will be minus, then you open the bracket. Okay, then you expand using number 1, so that will be cos beta, okay, times cos 30 degrees plus. Now, be very careful when it comes to this identity for cos. If there's a minus here between the angles, then there must be a plus there. Be very careful of that. It's a common mistake which learners do of putting a minus here instead of a what? A plus. That's a very, very common mistake. And it can happen without you knowing that it is happening. Right? Then sine beta times sine 30 degrees. Then you close the bracket. Okay? So I have expanded using number 3 and number 1. Alright? Then I need to simplify this. Now be aware that we have got 60 degrees here and 30 degrees. They are special angles. So your knowledge of special angles from grade 10 is required here. So this will become, now cos 60 is a half. So I can write this as a half times sine beta plus another, okay, that will be square root of 3 over 2 times cos beta. Right? Then, before I include this minus here, right, I have got cos 30 there, which is also equal to square root of 3 over 2. So that will be minus square root of 3 over 2 cos beta. And then another minus a half sine beta. Okay? So I've expanded and I've simplified using my knowledge of special angles. Now, at this stage, you have to be a guru of special angles. You should be able to see that there's a special angle here, then you simplify. Now, let's see now what happens. We have got a half sine beta, and we have got a minus a half sine beta. So these two, they give us 0. Right? Then we have square root of 3 over 2 times cos beta minus another square root of 3 over 2 cos beta. So these two will also give us a what? A 0. Therefore, our answer will be 0.
So 1 to minus the whole bracket.
What do you mean?
Like when you expand it, so 1 to minus the whole bracket, it'll say minus
because this minus, it affects the whole expansion. This minus it affects the whole expansion. So the expansion must be put inside the bracket because this minus here, it affects cos beta minus 30 degrees. And the expansion of cos beta minus 30 is cos beta times cos 30 plus sine beta times sine 30. Okay, so this minus here is very important. Any question? All right, so let's do number 6. So square root of 3 cos, so that's number 6. Square root of 3 cos, open your bracket, that's x minus 30. Right? Minus cos x minus 30. Cos x minus 60. Right? So again here, we are going to expand. Okay? please be aware that for the first term, okay, which has got cos x minus 30 degrees, this square root of 3 here is going to multiply the expansion. This square root of 3 here is going to multiply the expansion. So because of this minus, okay, because of this minus, we are going to use number 1 because of that minus. Okay, so because of that minus and that minus there, we are going to use number 1, which is the mother of the 4 identities. Right? So this will be the square root of 3 times, please be aware that this is the same as square root of 3 times cos x minus 30. So we just have to multiply the expansion of cos x minus 30 degrees by square root of 3. Okay? So that will be cos x so that will be cos x times cos 30 degrees, right? There's a minus there, obviously we put a plus as the right hand side there. So this becomes sine x times sine 30 degrees. Okay? Then we close the bracket. That's the first expansion. The second expansion, we need to take into account this minus here. Okay? So the expansion of cos x minus 60 degrees is going to be multiplied by a negative 1. That's what this minus means. Right? So we end up at minus, then we open the bracket. That will be cos x times cos 60 degrees, right? Plus sine x times sine 60 degrees. Right? Now we have got special angles as well, 30 degrees and 60. Therefore, this becomes square root of 3 times cos 30, that's square root of 3 over 2. So that will be square root of 3 over 2 times cos x plus sine 30 is a half, so that will be a half times sine x. Okay? I hope you are following that. Then, inside the bracket, we are going to have a half times cos x, because cos 60 is a half, plus sine 60 is square root of 3 over 2 times sine x. Alright? Now, I'm going to remove the brackets now. Okay? So if I start with the first bracket, square root of 3 times square root of 3, that will give me a 3. Square root of 3 times square root of 3 gives me a 3. Okay? Okay. Those who are sleeping, can you wake up, please? You are in class. You had the whole weekend to rest. Okay? Because I wanted to rationalize the denominator. Okay. Do you know that square root of 2, it's an irrational number? Right? When you say rationalize, means we are converting an irrational number to a rational number. Okay? We are converting an irrational number to a rational number. Okay? So to rationalize this denominator here, we have to multiply it by square root of 2, because if I multiply square root of 2 by square root of 2, it gives me a 2. And the 2 is a rational number. And that's what? Using a calculator. I'm not supposed to use the calculator. You're not supposed to use the calculator. Okay. If you use the calculator, we'll see that you use the calculator. All right. Sorry, everyone. Please be reminded. Can I have your attention? Can I have your attention? It's very important. It's very important for you to remember that you did grade 10, 3. You were taught special angle. You did grade 11. You were taught special angles. Right? Now you're in metric. I cannot treat you like it's your first time to do special angles. What you can do if you forgot, go back to your grade 10 notes, your grade 11 notes. Okay? At metric level, we don't have time to go back to the basics of special angles.
No, I'm not saying teachers, so like just write them down.
Okay. Can you write them? I'm gonna take them.
Yes, sir.
Can you write them down somewhere? I'm gonna take them. Write them down somewhere. Alright, let's start with sign 30. Sign 30. Why do I have to speak about this? Alright, sine 30 is equal to a half. Can you stop talking? Sine 30 is a half. Cos 30 is square root of 3 over 2. Right? Now, how do you get tan 30? Tan 30 you divide sine over what? Cos. So you don't have to memorize what tan 30 is. All you have to do is, we know that sine 30 degrees over cos 30 degrees is equal to tan 30 degrees. And what is sine 30? It's a half divided by cos 30, which is square root of 3 over 2. I'm showing you a technique which can help you here. To not memorize. If you know sine, you know cos, you should not stress about tan. Because tan is equal to sine over what? Over cos. Are you following what I'm saying? So this will be a half times 2 over square root of 3. So you get 1 over root 3. So tan 30 is 1 over square root of 3. Okay? I don't need to memorize what tan 30 is. But I just have to know sine 30 and what? Cos 30. Alright? Then let's move on to 60 degrees. Right? Sine 60 is square root of 3 over 2. Sine 60 is square root of 3 over 2. Cos 60 is a half. Cos 60 is a half. So what is tan 60? Tan 60 is going to be equal to sine 60 divided by cos 60. Okay, sine 60, that's square root of 3 over 2 divided by cos 60, which is a half. So we get half there, and this will give you square root of 3. So tan 60 is square root of 3. Alright? Then let's move on to 45 degrees. In fact, I was supposed to move from 10 to 45, but I did vice versa. But sine 45 is 1 over square root of 2. Sine 45 is 1 over square root of 2. Cos 45 is also 1 over square root of 2. Sine 45 and cos 45 are the same. Okay? They are both 1 over root 2. Since sine 45 is equal to cos 45, what does that mean when it comes to tan? It's 1. Because sine 45 is equivalent to cos 45. So tan 45 is a 1. Alright? Then the rest, if you want, you can use the calculator. Like the 90, the 180, you can just punch in your calculator. 270, you can punch in your calculator. 360, you can do it in your calculator. Alright? Okay, let's move on. Alright, so let's do number 3. What do you have time? Wow, my time is almost. But I can do it quickly. Okay? I can do it quickly. I can do it quickly, yes. Yes, I can do it. Sine 50 times cos 10. So number 3, sine 50 degrees. Are you following there? Right. Yeah, please be aware that some of you are playing around. I can see. But don't worry. Don't worry. Next term, it will bite you back. If you are not serious now, don't think that you end up having time to start catching up. There is no time. Because the work is piling up. The work is piling up. So it's better for you to be up to date with everything at that moment. All right, can you clear your desk? What's the red paper? Can you clear your desk? You just sit like you are gurus now. Can you pass around the cloth, please? Pass the cloth around. Pass the cloth. Why you don't want So you need to finish now.
Literally, guys, to go to one post. Honestly, I want to ask this as well. I have to. I should feel like I'm stuck on one. I want to ask her. She's moving so fast, and I'm actually so these ones. We feel
Oh yeah, yeah. Jangan karena
Right. Good morning, everyone. All right. And listen, before I start my lesson, can you open your message? I just want to see the weight which I gave you. But I didn't give you
not the most.
Good. That's probably All right. Can I have your attention? Can I have your attention? Can you take out your metric? I just want to see what you want. If you are talking, can you be quiet, please? Can you be quiet? I'm not checking if your answers are correct. I'm checking if you are tempted.